All right, in this video, we're gonna pick up a bit more complicated of a statistics approach called logistic regression. Now, this is still an approach that I think people who have not much experience at all with analytics or even coding will be able to do. But unfortunately, because it is a little bit more advanced, you won't be able to do this within a tool like Microsoft Excel anymore. You'll need to be picking up a form of software that can help you do it. There are plenty of packages and statistical programs that can do this, but I'm going to walk you through what I think is one of the easiest ways to do logistic regression, even if you don't have any experience with regression or using any kind of coding language before. So what we're going to do is we're going to use the Radiant package that will help us use the R programming code to do logistic regression. So you can do this by first going to the radiant-rstats.github.io page. And when you go there, you'll have this lovely homepage with all sorts of good, useful information on how to get set up, how to use Radiant, and how to connect it. But basically, R is the name of a open source programming language. RStudio is an interface that sits on top of it, making R easier to work with. And this Radiant is an application built by Vincent Nice of UC San Diego Rady that will enable you to have an easier time using a guided user interface, meaning you can point and click for what you need in order to perform some really good statistical analyses that can be used in all sorts of applications. So you start by going to the home page and then going to install. Follow the directions. It will load RStudio, and the Radiant application onto your computer. The application itself actually doesn't sit on your computer, it's web-based, so you will need to be on an internet connection to get it started, but you can work offline on it as well. After you've got it all installed, you'll be able to open it up and it will look something like this. So it will come with some pre-built in data for you. This happens to be a data sheet on diamonds being presented. And it will also enable you to add in your own data. You might want to play with it first, check out some of the how-to videos on the Radiant YouTube page, as well as on the homepage to get familiar and comfortable in it. And then when you're ready, you can go ahead and upload our data file. So I'm going to do this example with the same data file that was used in the Excel regression examples so that you can get a feel for it and maybe even recreate it yourself. So data sets will come with a couple pre-built ones about diamonds, one about Titanic. These are actually very popular used files. You can find many articles online where people explain how to work with these, or you can upload your own. So I already uploaded one and it was very simple. I go to this load data type section and I choose the type of file that I will be uploading. Now you can see that there isn't a selection for Excel here. So if you were working with an Excel type file and maybe it ended with .xlsx or XLS, then you would just want to go to that file and do a save as, and save it as a CSV, which stands for comma separated values. And you can do that with any Excel file. It will let you save it that way. And that's then what you'll want to pull from your own computer. This is true for any other Excel file that you might be wanting to work with. So you select CSV. You can leave these for most. What this is saying is that does it have header rows? In our example, it does. And how are factors set up? You browse to where it's located on your own computer. You upload it. It actually uploads very quickly. And once it's there, it will be in the options of data sets, and it will even show you a preview of the data. So in this case, I look at the data being displayed here, and this does in fact look like the file. I see many of the same variable names that we were working with over in Excel, and if I were to check the first 10 rows of data, they would look like this. So I know my data's in there. It's looking pretty good. I can spend some time doing some visualization, some pivots. I can explore it. I can even transform or recode some of my variables. I definitely always advise this first before building a model. So hopefully you can explore your data first before building a model, but let's assume that we did that and that we're ready to build a logistic regression model. Now, the reason that we would want to do a logistic regression model instead of, say, a linear regression model is that logistic regression is set up for when you have a dependent variable that is binary, meaning only one of two outcomes. So let's say that I wanted to do an analysis on employee attrition. Employees either leave the company or they're still employees. That's it. They either work there or they don't work there. That's binary. That's dichotomous. There's only two things. So I wouldn't be able to really do linear regression using that. I would have to do logistic regression because that's what it's made for. So then I can go into Radiant and I say I want to build a logistic regression model. If I go to the model dropdown, I'm going to see all of these lovely options. There's some really good other statistical approaches in here, but we're going to go specifically to logistic regression. When I select logistic regression, it's going to take me to a new page and it will already have my data in there because I loaded it, but it was going to ask me to enter what kind of information I want in order to estimate a model for attrition. So in this case, I want to predict attrition. Now, Radiant is very smart, and in this response variable option, it's only showing me the 4 different things that are in my data file that happen to be dichotomous. So it's actually telling me, hey, you've got 4 variables here that only have a one or the other option. Which one do you want me to use? Do you want me to use attrition, gender, overtime, or a performance rating? Which is actually showing as numeric, meaning there's more than just the 2. I'm going to go for attrition, so I'm going to select that bad boy right there. And then it wants to know which level I would like to focus on. So depending on what your labels are for your variables, it will show up differently. In this case, my data is marked as a no attrition or a yes attrition. And so in this case, I want to build it off of yes attrition. Doesn't actually matter if you choose to do no, you'll just have to keep that in mind with what you built it for. Had you have chosen no, you would have been building a retention model, meaning I want to predict who's going to stay, as opposed to building an attrition model, which predicts who's going to leave. It's the same data, same setup, it's just a different focus of which one you're looking at. And that will be your dependent variable, meaning that's the thing that we're trying to predict or explain. And then we need the variables that we're going to explain it with. What are the variables that we think either explain attrition or that might predict attrition in the future? And it gives you a list of all those good old variables that are in the file. We had a really long file, so it's got a really long list here. And you might go through and choose the variables that make the most sense for you. And you'll notice that some are listed as numeric, meaning the numbers keep going on. And in this case, age, for example, is at the top. And we might believe that age, which is a continuous variable, meaning you can keep getting older and older, might be related to attrition. How old someone is might dictate their likelihood to leave a company. And there are all sorts of other factors and numeric values in here that we could choose from. But let's just say I happen to notice in the response variable that overtime was a variable in there. So maybe I want to work with a factor like overtime. Do they work overtime? Yes or no? And because I've used it in a past example with age, I'm going to go ahead and do both age and hourly rate. And I actually was holding down the control key to enable me to select more than one. So I'm going to scroll back through and make sure everything that I want is in there. So age is highlighted. Hourly rate is highlighted. Now these are the same 2 variables that I chose to use when predicting a different variable in the Excel example. And I also selected overtime. So this is what I've told it I want to try out as my independent variables. And then there's got some questions down here. Now I'm going to leave all of these as they are, and I'm not going to explain them here in this video, but it is definitely worth noting that there are other ways to look at interactions, And there are some really important options down here, especially with things that can help you to identify whether or not you might have covariance issues, or if you want to build confidence intervals around your prediction to say how confident you are in the values that you predict. So there's a lot of good stuff down here. We just don't have time in this little video, and definitely if you keep going with using logistic regression, you should check those concepts out. Okay, so everything's in. I've got my response variable, or my dependent variable, and I've got my explanatory variables or independent variables. And I'm going to go ahead and press estimate model. Now Radiant is so snazzy that it just, boop, there's my results. And it's going to retell us what we're doing. So here's the data file that we pulled it from. Here's the variable that we're looking at. And we are focusing on whether or not, yes, people attrited. And we're going to see whether or not age, hourly rate, or overtime seem to have an effect on attrition. It's even set up to give you both the null hypothesis and the alternate hypothesis. Typically, anytime you're doing regression, whatever you're putting in as your variables for the prediction, that's sort of your hypothesis. That's me saying, I think age, hourly rate, and overtime have an effect on attrition. That's my hypothesis. The null hypothesis is always pretty much that there is no effect. So the null would be that age, hourly rate, and overtime do not predict attrition or explain attrition. And so when I think about something like assessing my p-value, if I get a significant p-value, that means I can reject the null, and that I might have support for the hypothesis that these things do in fact predict or explain attrition. And then I use the table just below to help me assess that situation. So in this table, I will get the OR, as it's listed here, or odds ratio of how we are seeing the data come out. I will also get the beta coefficients, the standard error, a standardized value, a z-value, and then the p-value associated with each variable. Now, I've already explained in the other videos how to really think about p-values and whether or not they're significant, but you can see here that Radiant has already indicated the significance level by putting these little asterisks, and we can see that both age and overtime are showing as being statistically significant in this model. And given that it has the 3 little stars, we can see that that means that it's significant at the 0.001 level. And so not only do we have our coefficients and our p-values, we are also getting a pseudo r-squared. Now, logistic regression does not have the same kind of r-square that a linear regression would have, and that's because the linear regression is based off of the linear correlation of 2 variables. That's why a correlation coefficient is really just squared to get your r-square. But there are other approximations that can be used to get an r-square-like value, and that is provided here. So in this case, the pseudo r-square is a 0.097. And what this tells us is that approximately 9.7% of the variance in attrition can be explained by age, hourly rate, and overtime in this model. 9.7%, probably not very high, but also we don't always in logistic regression see extremely high values. That being said, we probably would have expected something higher than that if we thought that this was a good model. We're also going to get the log likelihood values. Now this is because logistic regression does, and that's where the log in log likelihood comes from, does have to do with being built on a logistic shaped function, meaning that you can either be a 0 or a 1. You can't be anything in between. And so it'll tend to follow a curved pattern, not a linear pattern. And so you'll be able to get those values and assess whether or not you believe it connects. So this video is not going to get into how to build a good model. This is just meant to show you how to perform one in Radiant and get outputs and results. Good luck.